Good afternoon. I'm absolutely delighted to be here to talk about the work we're doing at the University of Surrey in collaboration with Modern Water. And the talk is about our desalination work and in particular the manipulated osmosis technology. But just a general background to the subject of water. Obviously, we're all aware of the water shortages in the world, and as a result of that, there is unfortunate impact on a number of people. I mean, like 20,000 people die, unfortunately, every day because of water-related diseases. There is also 1.2 billion people around the world which don't have access to excess water. Almost 50% of the world population also lack sufficient water purification system. But most importantly, and is a worrying point, is that water become a source of concern and a source of tension between nations and the potential of conflicts. But at the same time, water can be the catalyst for cooperation if nations choose to do so. And the forecast for the water index, which is actually happening right now in many parts of the world, if we see the most populated part of the world actually face severe water shortage as indicated by the color. And with that, even the UK and most of Europe actually, and even the southeast of UK, and we all know they will face the water shortages, and we have experienced this in the last few years with the hose bans and other water measures. To address this world, because we have only 10 minutes in this short presentation, so try to go quickly through the introduction. One of the options, and probably for me, one of the most sustainable options to address the world water shortage is really to tap into the sea. Simply because most countries in the world have access to the seas, but also most big cities, about 70% of the world's population live within about 50 kilometers from the seas. In terms of the commercial potential and commercial return for the technologies, and particular desalination, is quite high. You can see just the Middle East alone, which is account only 50% of the world capacity for desalination, talk about $31 billion in 2009, and this could rise to about 52 or more in the year by the year 2016, as reported by the Global Water Intelligence. And currently, the Gulf countries, as I mentioned, account about 50% of the global desalination, not because that's all can be done, but because the technologies are so expensive and only the Gulf countries or some countries in the Middle East have access to the financial resources to do so. Again, with the current desalination technologies, they're expensive, they're energy intensive, and obviously they're not easily accessible to many countries in the world. So step change in the technology is needed, and this is actually where our contribution at Surrey University came about. So the Surrey Aqua Technology and Modern Water story briefly started with the research and development of the University of Surrey over many years in the area of membrane processes, which led to a number of inventions and patent applications. This was recognized by the Royal Society Brian Mercer Award for Innovations, and the support from the Royal Society gratefully acknowledged, which allowed us actually to demonstrate the technology on a large scale pilot plant and set the scene for the commercialization process. So the company, Surrey Aqua Technology, was formed in around November 2006 with the support of the IP Group and other investors, and then a few months later, led by experienced financial experts and people with industrial experience in the water sector, led to the merger with Modern Water and the flotation on the London alternative market, raising £30 million. So within about 6 months from the formation of the company to the flotation, that sort of money was raised, which obviously allowed the company to focus more on developing the technology and the commercialization process. Further recognition for our work at Surrey was the European Academic Enterprise Award by Science Business. That was in 2008. And Modern Water was also awarded the AIM Sustainability Award in 2009. And within, as I said, the company led by experienced technical and managers led to the first proving plant of the technology within about a year from flotation, and the second and first commercial plant of the technology was operational in Oman since has been operational in Oman since 2009. And talking here actually about the story of the technology and talking about the water situation, I think it's fair to say something about the science to give it more, more satisfaction actually to the scientists. And the technology is a platform technology based around the osmosis process. We're all familiar with the natural osmosis process. I mean that if we have a salty water and there is a membrane which will tell the movement of the salt and fresh water on one side, water will diffuse naturally. And the diffusion actually of the solvent is a Latin word for osmosis. So osmosis actually is a diffusion process, is the movement of the solvent from a more concentration of the solvent, i.e. water in this case, to the saltier side. Fortunately, this process actually is the thermodynamic reversible process, which means that if we try actually to pressurize or apply hydraulic or hydrostatic pressure on a salty water, we could drive the fresh water to the other side. And this is actually the basic or the basic principle for the standard desalination process, reverse osmosis. But unfortunately, actually, if the source water, if the raw water is seawater, this gives a number of problems. Particularly in the common salt in the seawater is sodium chloride, which is a small ions and therefore requires tight membrane. Secondly, we all know sodium chloride or salt as a corrosive material, corrosive, and therefore a requirement for special material and obviously more expensive, plus other things formed or found in the seawater like other ions which give problems like scaling and so on. So the traditional conventional desalination process of reverse osmosis have some practical limitations. And then the innovations or the innovative ideas came from Surrey University, which what we call it actually manipulated osmosis, where we manipulate the osmosis barrier and by using what we call osmotic agents. And the osmotic agent actually, if we have the seawater in this side here, and here the number of ions, different type of ions available, the osmotic agent we choose and select will allow us to pull the water, only water from the seawater side into the osmotic agent solution. So from the science point of view, actually there is nothing new. It's just we are only moving from one solution to the other. However, from the engineering point of view, this is a huge step because by doing so, we are replacing actually the common salt in the seawater, which is sodium chloride, which is difficult to separate, by an osmotic agent, which we know well and we know how to separate, and it can over most of the practical limitations of the conventional process. So the next step, actually, what we do, we try to apply the pressure on the osmotic agent solution and get the clean water, but at the same time, actually, we can reuse the osmotic agent. So this could work like a sponge when you can take the water from the sea, squeeze it, and then reuse it again. Obviously, it doesn't work like this, but that's the principle. So as I said, the science actually is the same, but the impact on the engineering process is quite significant. And since then, obviously, the ideas, obviously, so simple and straightforward and obviously exciting, so there was no time actually to wait and verify this for a long time in the labs. So luckily, unfortunately, it was by pure chance I met with Neil McDougall, which led to the formation of the company and taking things forward in a rapid, I would say on a fast track. So the technology in terms of the commercialization, the first proving plant was in Gibraltar and has been operational and producing water to the public since 2009. And also the plant demonstrated that we can save up to 30% in the energy saving plus reducing of chemicals and other advantages and benefits. Oman is a key, the Middle East actually is a key market to this technology, and we've been fortunate to find a good partnership in Oman, and we start our first commercial plant in Oman, and again, it's been operational and producing water to the public since 2009. We have another exciting technology based on the same concept of manipulated osmosis, but for the water treatment of cooling towers, and this is now being operational or in a proving plant capacity in Oman as well. The benefit of technology, again, significant energy saving. I mean, the 30% actually is what we are comfortable to report. But obviously, in the plant in Oman, we are achieving more than that. But again, the older plant we're comparing with the older plant, which is an older technology. But then obviously minimizing discharge to the environment, reducing chemical usage, and most importantly, obviously reducing carbon footprint, reduce operating and capital costs, and a more sustainable and effective way of producing water from the sea. So in conclusion of this, we believe that desalination has undeniable potential and a key role to play in addressing the world water problem, not just in water stress area, but even in the UK, and you know of plans of having, for Thames Water having a plan in East London, and there are plans for other demonstration plants or units in other cities on the southeast of England. The concept or the technology or the platform technology developed at the university and now is the commercialization led by Modern Water is a unique process which offers a number of interesting applications in terms of low energy, low cost process, in terms of converting seawater into drinking water. And also the process offers significant reduction in capital and operating costs, but most importantly, and this is to me and to many researchers in my team, is if few lives could be saved from the 3 million people, 3 million lives lost every year, then something special will have been done. And coming here, actually, I thought we'd just say a few things about the current research activities at the university and in particular Center for Osmosis Research and Applications. We continue to work on desalination processes, whether it's membrane-based or thermal processes, renewable energy with particular reference to solar point and hydroosmotic power. Hydroosmotic power is very exciting, very interesting concept where we can produce power from the sea. As well as producing fresh water from the sea, we can produce power as well from the sea. And also we're working on other processes with the emphasis on low cost and climate neutral using electrical, chemical, and mechanical processes. And the long-term mission for us at the center is to be obviously a worldwide center of excellence in low carbon or low cost water treatment technologies. But the vision for Modern Water, and I said this before, I wanted to give the world the equivalent of Microsoft in desalination. And thank you very much. And I leave you this with the thought of, from my home country, Iraq, and I wanted to bring, hopefully one day, back hope and prosperity and water to this part of the world. And thank you.